Problem 7 is very similar to the other problems that we've done. We need to get the 5b over to the other side of our equation. So we have 5b squared plus 5b minus 6 equals 0. Let's write our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Starting to sing the Pop Goes the Weasel thing. Okay, so our next step here is to label our a, b, and c. So a is 5, b is also 5, and c is negative 6. So now we want to just plug those into our quadratic formula. So we have x equals negative b, negative 5, plus or minus the square root of b squared, so 5 squared, minus 4 times a, which is 5, times c, which is negative 6, all over 2a, 2 times 5. Okay, remember what our first step is. Our first step is to simplify the square root because it's like an exponent. So 5 squared is 25. 4 times 5, negative 4 times 5 is negative 20. Negative 20 times negative 6 is positive 120. It's like 2 times 6 is 12. 20 times 6 is 120. Okay, so we get x equals negative 5 plus or minus the square root of 145 all over 10. So we want to see if we can simplify the square root of 145. So what I recommend you do here is do 145, don't put extra stuff in it, 145, and divide it by your perfect squares that you know. So 4 is your smallest perfect square. That's going to help you because 1's not going to help you. And you want to see if you get any integers, any 145 divided by 25. Sorry, hard to do this while I'm talking. So you can keep trying numbers. 145 divided by 36 and on and on and on. You're going to see there is no perfect square inside of 145. So your answer to problem number, what number is this? 7? Yeah, problem number 7 is x equals negative 5 plus the square root of 145 all over 10. And oh, I forgot the negative. Sorry, negative 5. I said it out loud, but I didn't write it. And then we also have negative 5 minus the square root of 145 all over 10. As much as you want to simplify the negative 5 and the 10 to just be like 1/2, we cannot simplify those because there's no multiplication happening here. We're just adding in front of our square root. So we cannot simplify the 5 over 10. So you can either leave your answer with a plus or minus in it, or you can break it up in these two answers like I did below. But that is how you do problem number 7. All right, number 8, it's in a perfect form for us to actually solve this by square rooting like we did in number 9, not number 9, sorry, in 9.4 notes. But in these notes, we are learning how to use the quadratic formula. So we're going to solve this using the quadratic formula. So your first step for the quadratic formula is making sure it's set equal to 0. So if we subtract 13 from both sides, we're going to get 9k squared minus 13 equals 0. Now I have my quadratic formula over here on the left from problem number 7, so I'm not going to rewrite it this time. My a value is 9, the number in front of k squared. My b value, well, wait a second, I don't have a b value, right? There's no k in the middle. So my b value when I don't have it is 0. And my c value is that negative 13. Okay, so plugging things in, we get x equals negative 0, which that just means the same thing as 0. Don't be worried. 0 squared minus 4 times 9 times negative 13 all over 2 times 9. Okay, so zeros don't matter. Those are going to go away. So we just get x equals plus or minus the square root of negative 4 times 9 times negative 13. 468. divide all of it by 18. So as much as you would love to take 468 and divide it by 18, that's not following the order of operations. So the first thing we need to do is simplify the square root because that acts like an exponent. So this brings us back to the first thing we learned in distance learning, way back to 9.3. Okay, so square root of 468. You want to think of some perfect squares that go into 468. I'm going to try 4 just because it's smallest. Perfect, it worked. So 468 divided by 4 is 117. So 4 times 117. Now 4 is a perfect square, so I know I'm done simplifying that side. But 117, I want to see if I can simplify. So I'm going to go back to my calculator here. 117 divided by any other perfect square. Let's try 9. Sweet, it worked. Okay, so 9 times 13 is 117, and 9 is a perfect square. So I can rewrite this. The square root of 468 can be rewritten as the square root of 4 times the square root of 9 times the square root of 13 all over 18. But what is the square root of 4? 2. What's the square root of 9? 3. Square root of 13, we cannot simplify. And 2 times 3 is 6. So we get x equals plus or minus 6 square root of 13 over 18. Now, because there's no addition or subtraction sign in between anything and we are multiplying everything here, we can simplify 6 over 18. 6 over 18, both of those divide by 6. To give us 1 over 3. So this becomes x equals plus or minus 1 square root of 13 over 3. You don't even need that 1 if you don't want it, because 1 times anything is the other number. So x equals, for number, what number is this? 8. X equals the square root of 13 over 3 and negative square root of 13 over 3. So those are our answers for problem number 8. If you want, you can also leave it as just plus or minus, but I know Pearson has you write it as 2 separate things.